All right, folks, it's Bass Action back in action here. In this video, I'm going to go through two main things. The first thing that we're going to talk about is a summary of the various formulas that you're going to need to know. And then the second thing that we're going to go through is we're going to develop one of these formulas through this proof right here. It's going to be pretty intense. I've got it all laid out for you so you can just follow along and fill in, but it is still going to be pretty intense and you might need to pause, so keep that in mind. All right, starting up here at the top and looking at our summary of our formulas, this one here in the upper left-hand corner is really just our complementary co-functions. We've done this before. It's just another way of visualizing it, a little smaller summary of it, and also written in terms of radians. So we just need to remember here that pi over 2 is simply 90. So all we're saying here, I'm going to go ahead and fill in these 90s. All we're saying is that the sine of 90 of some angle, 90 minus theta, sine of 90 minus theta is the same as cosine. And then the opposite would be true. The cosine of 90 minus theta is going to be equal to sine theta. So if you want to review that, you could look back to those old notes, those old videos, or you can work through some basic SOHCAHTOA on this triangle, and you'll see that you get the same values on each sides of those equations. The next thing that we want to look at are these new formulas. These are going to be our sum and difference formulas, and you're going to be expected to know them. Now, they're not nearly as complicated as it appears. Like it appears that we've got 6 formulas here to memorize, but really there's only 3. You've got an equation that a formula you're going to need for sine, you'll have a formula for cosine, and a formula for tangent. And there are some pretty significant patterns here. So one thing that I want you to notice is that on the sine formula, if I'm adding the 2 angles, I'm going to add in the formula. So this sine is going to be the same. So on sine, the sine is the same. Okay. Now on cosine, however, if I'm adding here, I'm subtracting here. So on cosine, the signs are different. Okay. So this is going to be different. That's important for us to remember. You can see the same was true on the subtraction. If I'm subtracting, I'm subtracting. So again, signs are the same on sine. The signs are different on cosine. On tangent, we're going to notice that the signs are the same in the numerator, but they're different for the denominator. Okay, so the first thing to think about is the signs. The next thing is the pattern that we're going to be looking at. So on sine, when we're looking at our pattern, the way we can say it in our head is sine, cosine, cosine, sine. So sine starts with sine, and then the pattern is sine, cosine, cosine, sine. And then the A's and the B's simply follow the AB order that's in the problem. For cosine, cosine's going to start with cosine, and its pattern is cosine, cosine, sine, sine. So we've got sine, just a second here, let me highlight those. So we've got sine, cosine, cosine, sine, and then cosine, cosine, sine, sine. That's going to help you keep track of it. The same thing is going to be true about the AB. So I've got an AB pattern here, AB pattern here. On tangent and the numerator, we're going to add the tangent values for the 2 different angles. In the denominator, we're going to have 1 minus their product. Okay? All right, let's jump into our proof. Now, like I said, this proof is going to be pretty intense of what we're going to have going on here. So in this proof, we are going to develop the cosine formula. The cosine formula is going to allow us to develop the sine and the tangent formulas in the next video. So this is the formula that we're trying to develop here. We're trying to understand how we get to this cosine, cosine, sine, sine with a plus in the middle. It's going to come down to this picture right here. So what we're going to do is we're going to look at these 2 different angles that I'm going to have here. I'm going to start with this point right here at S, and I'm going to have this angle of rotation that's landing at S. And I'm going to write this point S as an ordered pair, and I'm going to call this first angle of rotation my angle A. Okay, so point S is going to represent the rotation for angle A, which means point S can be expressed as the cosine of angle A and the sine of angle A. Okay, just taking us back to how we wrote things for our unit circle. Now, this point Q is going to represent our angle B. So this is going to be our rotation for angle B, and then point Q can be expressed as the cosine of angle B and the sine of angle B. All right. Now, what we want to understand is what happens when I subtract these two angles. If I've got this black angle right here and I'm going to subtract the red angle, where would I land? Well, if I take the black angle minus the red angle, I'm going to land somewhere here in the middle. So I'm going to draw in that triangle. I'm actually going to draw it in here with blue. I think that'll actually still show up for you guys. And I'm going to call this point right here R. Now, if this is point R, I could express this as the cosine of R, sine of R. But I understand that I got this new angle R, this new rotation of R, by taking angle A minus angle B. So I'm going to write this as the cosine of A minus B and the sine of A minus B. Okay, that's going to be my expression for point R. Now, what I want to do is I want to understand how all these points relate. So I'm going to kind of draw in this segment SQ. And what you kind of have to do is you have to visualize this SQ right here, this angle right here, that would also be the black angle minus the red angle, which means this angle inside the triangle is actually the same as this angle right here, okay? Now, that means that I can draw in this segment RP, and I know our picture is looking kind of crazy, but that's okay. We're going to leave the picture here in just a moment. But that means that segment SQ and segment RP are actually the same, okay? Because the angle inside this triangle was the black minus the red, and we said that angle R was also the black minus the red. So that's what we're going to put down here in our little blank. We're going to say that RP, it's kind of a messy R there, RP is going to equal SQ. We're going to use that then to develop our whole distance formula right here. So we're going to start filling some things in. And believe it or not, even though this is going to look crazy, this is really just going to be a bunch of simple algebra. So I've got this RP and SQ. You can see I've got my square root symbol set up to do my distance formula. So for segment RP, we're working with this one right here. We need to subtract our x values. So we're going to start here by saying the cosine of A minus B minus the cosine of, or minus our 1. Sorry, I just realized I forgot to write in this ordered pair here of 1, 0 for my RP. So I'm doing RP, and this point right here, P, is the point 1, 0 on our unit circle. Jumped right in, and my eyes were drawing to here. We're doing these two x coordinates right here, cosine of A minus B, and then this x coordinate of 1 at point P. Sorry about that. Now what we're going to do is we're going to subtract the y coordinates, the sine of A minus B, and then the y coordinate of 0. That one, sine of A minus B, and the y coordinate of 0. That gets me segment RP. Now for SQ, I'm going to look at these two ordered pairs right here. So cosine of A minus cosine of B. And then I'm going to do sine of A minus sine of B for the difference of the y coordinates. Now notice that I did also fill in for you already. I filled in all the other little parts about our distance formula. I've got our square root symbol. I've got our quantity squared. I'm going to add. Then I've got the quantity squared. So the difference in the x coordinates squared, the difference in the y coordinates squared, and I did the same thing over here. Difference in the x coordinates squared, difference in the y coordinates squared. Now what we need to do is we need to start solving. So to solve this problem, we know that we want to square both sides of this equation to get rid of these radicals. So I know that really what's going to happen is these radicals are going to cancel out, so I'm just going to mark those out for myself right there. Now I'm going to start expanding. We need to expand this whole thing. So we're doing cosine of A minus B minus 1 times itself. So that means I'm going to have a cosine squared of a minus b. When I FOIL, I'm going to end up with 2 cosine of a minus b, and this minus here tells me that I'm going to need a minus right here now. Then, of course, since I'm squaring, my negative 1 squared is going to become a nice plus. This plus here is going to give me a plus right there. When I square this piece, since this is just a 0, I really just need sine squared of a minus b. So that part's going to be done. Now I'm going to move to this right-hand side. And when I square this side, I'm going to get my cosine squared a right here. Again, I'm foiling, so I'm going to have 2 of this product. So that's where this 2 is coming from. Since it's minus, this is going to be a minus. And then, of course, since I'm squaring, the cosine squared b is going to be a plus. This plus again is going to go right here. And then I'm going to repeat the process of foiling. Sine squared a minus 2 sine a sine b plus sine squared b. Now, this looks really crazy at this point, but now things are going to really start to clean up for us. So as we start to clean up, we're going to start to use our Pythagorean identities here. What we're going to notice is that we have this cosine squared a. Let me scooch that over here. I'm going to have this cosine squared a minus b and this sine squared a minus b. Well, cosine squared plus sine squared is just a 1. So this 1 right here, these 2 together and this 1, together with this 1 right here is going to give me a nice 2 right there. And then my minus 2 cosine AB is right here. Now on the other side of the equation, I'm going to grab the cosine squared A, and then I'm going to have a sine squared A. Those together are going to give me a 1. Then I'm also going to have a cosine squared B and a sine squared B, and those together are going to give me a 1. So that's going to give me a nice 2 right here. Then I'm still going to have my minus 2 cosine AB and my minus 2 cosine or sine A sine B right here. From here, the next thing that I'm going to notice is I'm going to look at all this stuff and how it's cleaning up, and everything here is divisible by 2. So I'm going to go ahead and I'm going to divide everything through by 2. So that's going to give me a 1, and that 2 is going to go away, and this is going to give me a 1, and that 2 is going to go away, and that 2 is going to go away. Now the next thing that I can see is that each side of this equation has a 1, so the 1s themselves can just cancel. If I subtract 1 from each side, the 1s are gone. Lastly, I want to call my attention to the fact that I have a minus still, and a minus, and a minus. Since all of those are negative, I am going to go ahead and imagine that I have multiplied through by a negative 1, thus flipping the sign of all of these negatives to positives. Now I'm down to my final answer. Here is that beautiful cosine of A minus B that I was trying to get to. And then I am left with right here and right here. I've got my cosine A, cosine B. Now we've got that plus that we were looking to create, sine A, sine B. So there is the whole development of how we get that cosine, cosine, sine, sine pattern, and why when it's a subtraction of 2 angles, we end up as a plus. Now, in the next 2 videos, we will look at the development of the tangent and the sine, and then in the video after that, we'll actually look at some examples.